Okay, hello everyone. Nice to see you all in real life. So it's been a little while, so go easy on me. We'll see how this goes. I've got some slides. I think we're going to go through. There's maybe might drop into a little bit YAML. I apologise in advance, and then we're going to also try a bit of a live demo. So yeah, hopefully everyone keeps their fingers crossed, and hopefully we'll get through the next 50 minutes together. Okay, so I totally imagine there's a lot of talks that people go to and they start off with this screen. I totally get the irony of coming to talk to you about a new project whilst also starting with the complexity of the ecosystem. It's not lost on me, but I think where I really wanted to kind of start this whole start from here was about the explosion of innovation and that's in the software industry right now. Trying to build and develop software and run software can be quite complex, given all the new innovation, new projects, new ways of doing things. Combined to that with the other areas around DevOps and new ways of working, there's lots and lots of new pressures and lots of new complexities. So really just wanted to start by taking a step back and just taking a big look at the big picture of, as a software developer, there's so many things, so many complexities in this new age world. So not everything on that CNCF landscape list people will relate to, and sure, there are people in this room that will relate to different things that we're going to talk about today. We've been talking about some different personas. We have application developers who will kind of want to, really working on that feature level development, coding, delivering features, working through their backlogs, in maybe experimenting, innovating, but really want to get in their IDE, working in their Git providers and pull requests and things. And then we'll also have our application operators. So these are people that are really responsible for where that application is going to be deployed to ensuring the quality, ensuring the uptime of that application, looking at metrics, resources, to keep the availability and the quality of that application going. Maybe this might stretch into your SREs, it might be your DevOps people as well, but this is kind of where we're talking around application operators. We've also identified another persona around platform operators, possibly looking after the clusters, responsible maybe for more security elements side of things, ensuring the security of changes coming in and going out of clusters, and the credibility of your systems. And the reason I bring this up is because I think some people will relate to one or more of these personas as we go through some of these slides. So if there is some slides that are probably drifting off to a bit of YAML, I apologize. We will come back to hopefully a bit more interesting afterwards. Okay. So software delivery. Building any software ultimately gets into the delivery side of things, and there's quite a lot of assembly required, especially in this new age around lots of people using Kubernetes as a runtime, but lots of applications or systems actually using Kubernetes to be able to build your applications as well, ensuring the quality or the security, credibility of those applications. So we have lots of assembly that's actually needed, ensuring like registries and credentials, secrets management, continuous integration, continuous testing. So there's lots of this complexity that's starting to evolve. And then combine that with the first slide, there's lots of different projects that are coming up to try and solve these problems as well. That's where this other level of complexity comes. So we've been doing some thinking around this and how we want to make it easier for people to be able to construct this path to production. Including kind of the innovation that's happening out in the world, in the ecosystem, but also using your existing systems as well. So how do we start to ease the way to be able to interact and call different systems, and so we can also plug in the different parts so that we can evolve as we want to evolve. So if we want to evolve to more cloud native approaches, if we've got significant investments in existing more traditional approaches today, how do we go forward to be able to plug in different approaches in the future? So this is where we're going to talk a little bit about an OSS project called Cartographer. Cartographer is open source, as I said. It's a supply chain choreographer for Kubernetes. It's a big, long word. We're going to go into. We've got a slide on that in a bit, so we'll dive in. We won't dwell on that quite yet. It's Kubernetes native, so it uses Kubernetes custom resources. It extends Kubernetes in the way that Kubernetes is supposed to be extended. And it also provides abstractions. Provides abstractions for developers to be able to focus on developing, working on their code, on their applications. It also provides abstractions for application operators as well to be able to help define that path to production. So there's a few objectives there that Cartographer is aiming to help with, and more. But I would say there's links at the end that you can kind of go and have a little look. There's lots of information on the website, lots to explore as well, and to get involved in as well. Okay, so started talking a little bit about abstractions. Here we've got some, I don't know if you can see at the back there, but those kind of abstractions we were talking about, or those personas we were talking about at the first slide. We've got this developer who's working on maybe Spring applications or maybe some Ruby code or some Golang projects. So we really want to encourage, keep developers, helping them kind of working within their IDE and working on their applications, their microservices. And then we have this abstraction called a workload, which we'll see shortly a little bit more. But then the idea is that developers own this workload and they keep on developing and coding, and then they work against that abstraction called a workload. Similarly, on the left-hand side over there, you've got your application operators, your SecOps or your DevOps folks that are kind of more responsible for those supply chain activities, how the application is going to be built, or how it's going to be verified, how it's going to be secured, how how it's going to be packaged and run, potentially Kubernetes manifests, how they're going to be managed. How do we ensure that we get health endpoints be added and resources and various other things? So the idea is that we've been looking at how we have good abstractions that can make sense, that help developers and also these application operators working effectively, having that separation of concern. So today, this is possibly people can relate to deploying an application today. Folks might have an idea, they'll do some coding, maybe hack together a Docker file, maybe create an image or push an image to a container registry, ensure if you've got permissions. Granted, a lot of this will probably be automated in places as well. They'll probably create some Kubernetes YAML as well for deploying that. Maybe it might be a job or a replica set or a deployment. They'll add in maybe some best practices, some actuator endpoints or some health endpoints, readiness checks and other things. Then they'll configure a service or an ingress, how to access that application. It might be Knative that they're going to be using, Knative routes, or maybe they need an ingress as well. Then they'll apply that somehow, and then eventually you get this running app. At some point, I think folks can kind of relate to this. And what we've been trying to look at, how do we, taking those abstractions we're talking about, how do we take that idea and code and allow developers to keep iterating at that level and not necessarily be too concerned or have the burden sometimes of what's happening within that supply chain, of the packaging of the application, of the validating, verifying and running of the application. This aim, and they're totally, from the start, some folks will wear both hats, totally understand, but this is more around just trying to draw some lines so we can help people actually focus on where they want to be focused. So as part of that, we've been looking at how those supply chains could look. Again, going back to the very first CNCF landscape, there's a lot in there, and there's growing more projects all the time. For example, there's projects for watching Git. Flux does one, or there's Argo CD does another. There's other ways you can watch for Git repositories. There's Tekton, personal favorite of mine. Tekton is a cloud-native pipeline orchestration engine and really helps enabling with open APIs to be able to build your continuous integration, continuous delivery pipelines. There's going to be other things that people are building out there. There's one in the middle there is build an image. So there's cloud native build packs. There's other Kubernetes operators, for example, that actually work with cloud native build packs to building images. maybe generating Kubernetes YAMLs. There's actually over time, there's more and more continuous scanning services, and more projects are actually being built in the Kubernetes native way. So more than just what's in the from a pipeline, these are specific projects that are actually running the deployable things in a cluster that help solve some of these problems about taking that path from idea through to running in a live environment. Okay, so kind of glossed over it before, so kind of come back to this. This is this idea around choreography that I mentioned. So for a bit of background, so my history comes from continuous integration, continuous delivery, working with pipelines. So I'm never trying to replace anything that's a pipeline, for example. The pipelines and pipeline orchestrations certainly have their place, and they are right for what job they do. One of the things we wanted to look at was taking a step back and almost a higher level, looking at the activities of what does multiple things have to do within that path to production. So sometimes it's not enough for just one pipeline to do all these activities and where that's owned, and running constantly that one process to take that job, either if it's in Jenkins or if it's in Tekton pipeline, continually that job running, taking that path change right through to production. There has to be different quality gates. It might take a week or several weeks for a change to get through in some organizations. There's different quality gates that we need to pass through, different security checks, different levels of approvals. This can be quite complex, and growing number in these age of governance as well, and policies that we need to prove that can be more than just what a pipeline can actually do for us. So how do we actually automate above that in itself? And this is where we're looking at choreography as well. So from pipeline orchestration, you typically get an event. The orchestrator will receive an event, whether that's a Jenkins server or Tekton triggers, for example, receive an event, and that would be a trigger, maybe a Git change, and that would trigger the pipeline. With choreography, what we're saying is slightly different. The shift is more into the services that are actually running inside the cluster. So say you might have a CI, or you might have a security scanner, for example, running inside the cluster. If a security scanner has new CVEs detected that it needs that were detected overnight, that became announced overnight, then you want to perform another CVE scan for all of your applications. The event is coming from the security scanner, but we can actually then trigger the software supply chain from that point within the sequence of the supply chain. So where I'm trying to say is the events don't necessarily come in from the orchestrator. The projects that we're building, and as innovation continues to evolve to solving these complex problems, they are going to be triggering these events themselves. And this is where the choreography comes in, to be able to coordinate these sequence events from multiple different sources. It's a bit blurry, I apologize, but this diagram kind of goes to show that it's from triggering a pipeline. It's that's our traditional approach, where we hear from trigger a Git commit, and that will trigger a pipeline. But there are lots more events that can actually happen. Say you might add some new UAT tests, for example, or security scans that we mentioned, or maybe there's some new conventions. Like for, let's say, say we want to ensure that all applications have a health endpoint or readiness check. Or maybe we want to we're using build packs and we have a new base image. Maybe we need to add in an environment variable to all our applications to disable some Log4j features, for example. There are certain places within that supply chain that actually can take in changes, consume changes, and actually we want to run through those supply chains and have those affect our applications running. So it's not just about Git sources. Okay, and I did brace you for this, for the YAML. It's not too long, I promise you. So we're talking a little bit about those abstractions. So at the top right, you can see from an application developer, we wanted to create an abstraction that was a reduced amount of YAML, let's say. Now, this bit of YAML here is called a workload. It's actually a custom resource within Cartographer. So it's an API custom resource. You see it inside the cluster. If you do kubectl get workload -o YAML, you'll see this. And what this means is this is a way for a developer to tell the cluster information about an application that they should be interested in, that the cluster should be interested in, that they will want to be able to build and test and package and deploy and run this application. But all this is doing really is actually telling a little bit about the application itself. In here, we're saying that it's got some tests, so you might have some Maven tests or some Go tests. It's also identified this is a web application, and we'll explain why that's important shortly. It gives it a name, and right at the bottom there, if you can see, it's actually got a Git reference. This could also be an image reference as well to an image container registry, or shortly an artifact repository if there was a jar file in the artifact repository, and so on and so forth. So this is the minimal amount. There's a bit more we can add into this, like service linking as well. Service requests. But as a minimum for this tour, I just wanted to kind of highlight this small 13 lines of YAML that the developer would actually use as that abstraction to interacting, to telling a cluster to be interested in my microservice. I gloss over this slightly, but this is where, and again, I don't really want to go too much into the YAML, but just more about some of the concepts. This isn't an exhaustive list of the custom resources that Cartographer uses. There's some good READMEs and tutorials out there, but I just took a subset of some interesting ones that we're going to hopefully see that help us with the live demo shortly. So this is a cluster supply chain. So the supply chain itself actually defines what type of applications the supply chain is interested in. Now, going back to that previous slide of the workload, when I said that was a type of web, and this cluster supply chain is saying this supply chain, this sequence of events that's going to happen within the supply chain are going to apply to all types of workloads for web. Now, the reason why that's interesting is because it's slightly different to what we're probably used to already. There's a bit of an inversion of control going on here, where, because at the top right, the application operator is responsible for writing and building and maintaining these cluster supply chains. So it's the application operator that's responsible for choosing what workloads can be run, rather than a workload or a developer saying, I want to pick which supply chain or which pipeline to use. So it's really putting that responsibility, the ownership on the application operators to say that if any change is going to come into my cluster, it will be signed, it will be packaged, it will have security policies applied to it. It will be built in a consistent way. It will have these base images used. So it really helps kind of have that standardization of your supply chains. Whereas, as opposed to coming from the other approach of your pipelines, you're choosing in your Git repository what path to take. It's not the control, the control is inverted and is put on the supply chain. Okay, and so this is where there's some resources as well that describe these cluster source templates and different types of templates. We'll dip into that a little bit shortly, but they might be for, say, Git cloning or building an image or doing a security scan or any number of things. And also, those resources that we're referencing here, those in turn will actually emit values themselves. So within the custom resources that they use, they will actually change certain state. And Cartographer is going to watch for those states and be able to coordinate the sequence of events moving on to these different resources. We'll see. Well, I'll explain a little bit better on that one shortly. Okay. Taking one of those examples of the cluster source template, what was being referenced in that supply chain. You can see at the top, there was the kind of a cluster source. Are all folks familiar with Kubernetes? There's a few. There's a few that's not. Okay, so for those that's not, bear with me. It won't be too much longer, I promise. So we've got some Kubernetes resources here. This is how we extend Kubernetes. And so these are Cartographer specific. And what this is doing is it's saying Cartographer is actually referring to another type of custom resource down here in the red box, and this is actually owned by Flux. This is a Flux custom resource. So what it's actually saying is that when a workload is created, this supply chain that's been curated by the application operator is going to create a Git repository resource, which means the Flux operator running inside the cluster is then going to start watching that Git repository. Long story short, the idea is that the supply chains referring to resources that are owned by other controllers within that cluster that have responsibility for certain things. And this is kind of where the ecosystem's slightly going, is around these, Kubernetes native, more operators, and we want to be able to coordinate and work with these different operators. One other way as well, you've got these runnables, you've got a cartographer runnable, so you could actually reference something. This would actually link to an immutable object inside the cluster. So say, if anybody's familiar with Tekton, you might have some Tekton pipelines running inside the cluster. This is a way that with using a runnable, we can actually reference the supply chain to actually use these Tekton resources as well. So again, it's not a replacement from a CI or CD tool, it's actually working out how we integrate and work with these as well. Slightly similar, but only bring it up because we're going to see this in the demo. There's also something called a deliverable. And notice it's very, very similar to what the workload YAML that we were using. On the top right, though, this is actually owned by the application operator. A deliverable is used to actually help describe in a cluster or in an environment, where what application configuration needs to be applied. What I mean by that is, an application operator can go into a cluster and they can actually point to this deliverable to a Git repo, which we're going to use. We're going to publish generated configuration from our supply chain using GitOps to be able to pull in and consume published, released changes into my cluster. So this is just a little way, but there's actually an RFC on the Cartographer open source project, if people like getting involved in this, to actually simplify some of this because there's some similarities. We'd love to get your feedback and get your involvement in that as well. And just to last one of the YAML, I promise. This was the cluster delivery side of it. So again, similar to the supply chain, but this is for the continuous deployment. What this is doing is just referencing the resources. So we're going to do a GitOps source, so we're going to consume configuration from a Git repo, and then we're going to do a deploy. Now you could plug in different types of deployment. That might be, again, using Argo, cat controller, might be kubectl in the job, any number of different ways you want to deploy your application. But also you can extend that and also add automated testing onto that as well. If you want, as soon as an application is deployed, could you want to run end-to-end tests, for example? Maybe you want to do some other activities at the end of that after everything's been verified. Maybe promote out into a different cluster, for example. How is all this done? I lied. I totally lied. This is the last one, I promise. So how is all this done? Okay, so the idea of these, when we're in Kubernetes land, we have these custom resources. At the bottom in this square box here, we tend to typically have statuses of actually what's happening. So at the top, we could say that there is a Git's being used to clone this URL, and the last status happened, it fetched it, it was successful, and here's a URL, a zip file of that source file. Now on the left-hand side of the cluster source template, that's where we're actually referencing the status artifact URL. So here we go, status artifact URL and status artifact revision. When Flux actually consumed that and pulled this down, we got status artifact URL and status artifact revision. So now we have a zip file that we can actually consume for all the other resources, the other operators within the cluster. So that's how this is all working. And so you might say, and to quote, I think, Maurizio, you had a blog on this, you mentioned this, around almost like an operator of operators. So as we continue to grow and build and adopt more Kubernetes approaches, more and more of these operators are going to be created. And how do we coordinate the activities and statuses between these? And this is where Cartographer is focusing on. And that's not to say, and hands up who can guess which was the last slide I tried to get in today. But the idea is it's not to say that it's just for that Kubernetes. Cartographer is built in Kubernetes native, and it's watching for these Kubernetes events, these custom resources. But it's not to say that we can't develop controllers that actually work with external tooling, external CI tools like a Jenkins, a Bamboo, GitHub Actions, and we're certainly going to be looking at in the open source community. If you're interested in that, then come and say hello. But the idea is that we can consume and return certain state, like those statuses or updates that we have, turn that into the cluster that Cartographer can work through, and then can stamp out and then continue the sequence of the supply chains. And with that, I think I went quite fast. I'm going to drop into a bit of a demo. Going a little bit quick, but folks don't mind. I'll take a little breather for a second. We're going to use, for the demo, we're going to use Tanzu Application Platform. Just a very quick couple of words on that. It's a Tanzu Application Platform. It is a collection of open source projects with some with extra developer experience all glued together. It's a product that Tanzu have. It's relatively new. Came out end of last year, which I'm involved in, and we're going to use that to demonstrate the parts of Cartographer that we've described in this in this session. So. Some of those open source projects include Cartographer. We said about cloud native build packs. There's something called KPack, which is a Kubernetes native way to be building these things. Also things around, say, Backstage, which is a extensible GUI, which is, in fact, this is Backstage here, which is quite nice. For developers working with any APIs, this is really kind of cool because you can register your application with Backstage, and you can then get all your documentation, all your APIs, your Swagger endpoints, and everything all kind of coming together. Which I recognize some people might be more interested in that side than the supply chain side that we're talking about today, but maybe we can talk about that afterwards. What we're going to do, are there any Spring folks in here today? People who've used Spring? A couple? Yes. Okay, cool. So we're going to use a Spring app. So this is using Backstage from that we're using with TAP. We're going to refer to Tanzu application as TAP. Otherwise, my mouse is going to fall over every time. We're going to here we're using an accelerator. So we can see here we're going to select this one, this Tanzu Java web application. Let's move that to the top. What we're going to call this? We're going to call this Tanzu Java web app Devoxx, and we're going to have that, give that a name, and we're going to generate this accelerator. We're going to download a zip file, and I'll just tell you, just before this, I actually went to connect to a cluster, and just back of the hotel room, I thought, right, I'll just clear out the downloads folder, make sure everything's clear. Well, there were some CLIs that were actually in my downloads folder, which kind of broke this entire demo about 5 minutes before this talk. So if there was a bit uneasy start, then that's why. But we figured it out, so I think we're good. So fingers crossed. We're going to, let's go over to a work folder. Let's copy that accelerator. Let's copy downloads. Ooh. Downloads. There we go. Let's copy this to here. Let's open that up. So this is a very simple Spring application that we're going to see. Tanzu. No. What was it called? Did I do that? CD Devoxx. Where did I go to? Oh, I went in there. Let's just go there instead then. Okay, there we go. That's better. Git init. Git add all. Git commit. Minus a minus m. Initial check-in. Right, so we've created from an application accelerator within Backstage. We've selected the application, which, by the way, you can publish your own accelerators into as well, which is kind of cool. Remembering taking advantage of some of those API features of Backstage. Definitely go and check it out. We've downloaded a zip file, and then we're going to create a brand new Git repository. Let's go and actually... Now, again, from a developer, this is probably what you're going to do. And maybe you will have access to creating Git repos, maybe you won't. Maybe you'll need to ask your friendly operation teams, infrastructure teams. Here, I'm going to create a new Git repo for this application. Let's have it private. There we go, create repository. I am just going to give it access to... I've got a little bots that we actually can add in here, so we can actually read from this because we want to keep this private. There we go, read access. So now we can go back to our application, and we're going to push up our changes. So as an application developer, we've got our quick start, we've got our application accelerator, we're happy, we've created our new application. Good, it's in GitHub. Excellent. Secondly, what we're going to do, just very quickly, one more Git repository. Now, you can change the cardinality of this because I mentioned we're going to use GitOps. So our application that we're building here, if you notice, doesn't have anything really in there to actually help describe how it's supposed to be built or run on Kubernetes. We're going to actually generate that, and we're going to publish that into a separate Git repository. The reason why we use a separate Git repository is probably from separation of concerns in itself, because developers are going to keep on iterating on this Git repository for this application source code. We want a separate Git repository that people can approve changes into, and you have traceability. Those changes will be reflected inside the cluster. So the idea is this second repo that we're going to create. Let's call that DevOps GitOps. Let's call that DevOps GitOps. This is going to contain the configuration that we generate, and we're going to subscribe to that. The run cluster is going to subscribe to that and pull in those changes once it's there. Let's add that and add people. Again, our bot that we're going to add, and give that right permission. Okay, done. So next, we've set up everything. Next thing we're going to do is we're going to do that, create a workload YAML. Now I'm going to use, let me just do that. Here's one I wrote earlier. This here, let me see if people can see that. Move that up a little bit. Let me talk you through this. This is effectively creating that workload YAML. It's a Tanzu CLI. I could write out that YAML myself and then just apply that inside the cluster. But it's effective. We'll go and see what it is afterwards. It's effectively the same as on that slide that we saw. So that reduced amount of YAML that we want developers kind of having to work with. It's going to create a workload. We're going to name it something. Let's do this to have some consistency so we don't get lost. We'll do this one as well. And we're going to say, yes, it's got some tests. Oh, we're also going to say what the repo is. Where was our repo that we just pushed our code into? Here. Okay. And we're saying it's of type web. Here we go. So that's now our supply chains have already been pre-configured inside the cluster. So they are watching for these type of web applications that are going to be created. So let's give that a go. Okay, that's just been created. So the green bit here, and that looks very similar to the YAML that we had on the very first YAML slide we had. Now, what's interesting around this is that's now, because the supply chains were actually already running or watching for these types, we can actually go and have a look at that's happening. We can tail some logs, which aren't that interesting, but let's just go and check that something's actually happening. Anytime now, fingers crossed. A sip of water. And how long we go to go, wait, yeah. Let's do that now. DevOps.
With the previous command, did you apply the workload?
Yep, workload will be in there. Who doesn't love a live demo? kubectl. So a little bit of Kubernetes here. kubectl get workload. And time. Good. Oh, rejected by the API service. That seems interesting. Let's have a little look at that. Oh, it doesn't like. Maybe I'm in the. Let's try and move over to another namespace, shall we? And in fact, what we could do, so I was actually in a different namespace to what one I should be in. So if I do that again, let's do that again. Fingers crossed this time. He confidently walks to the water. Yay, no doubt at all. Okay, phew. Right, so something's happening and some activity is actually happening. And I don't want to, really hurt your eyes by following the terminal because this isn't going to get any better if we continue to do that. We could switch over to that backstage instance that I mentioned before. So here we can actually see we've got our, this is the workload that we created, so we've selected that. We've got some things that are actually happening. The reason I show this is because this is a little bit easier on the eye than that YAML that we were kind of having to look at earlier. YAML is the building blocks that we're using for Kubernetes. I think many of us will agree that it's not really the most user-friendly thing to have to work with. And this is where we're actually building up this tooling to be able to help understand what's going on. So let's just keep that, may as well keep that going in the background. Or we can see that the first part, we talked about this source provider. It was a Git repository. So that was Flux, was actually went and said, yes, here we go, Flux, went and retrieved the source code from my Git repository that I created. My supply chain, now as a developer, I didn't know what was going to happen, but my supply chain is then actually, because I've configured a Tekton pipeline inside my cluster, it's actually gone and run the tests for that application. That was actually successful, so that's great as well. We're going to do some source code scanning. We're also going to build an image now. We could use Canico if there was a Docker file in there. We're going to use Kpack for the cloud native build packs. And if we switch over, we'll probably start to see some of these parts as well. This is where build packs is doing its thing to identify what language we are running. We're trying to build. It'll build that image. It'll then sign that image or publish that image into a container registry. And so that should happen anytime soon. But all the time then the developer can visualize this, but then isn't having to configure any part of this. The application operator will probably want to understand, if things are going wrong as well as the developer, but communicating those errors or any failures coming back to the people that are interested is one of the key things we're looking at here. So it might take a little bit of time. How are we? 13 minutes left. Okay, we're doing good. This is kind of cool as well. So this is actually, as I mentioned, the supply chain. This could actually be come at different source points. So this actually doesn't necessarily have to be quite linear as traditional pipelines. You can actually have these separate source inputs. As that slightly blurry diagram came up from the start, we could have different source inputs coming into the source scanner, for example, or the image builder as well. So this graph could actually start to grow. Similarly, we're capturing the deployment side of this as well. If you've got multiple clusters, how many clusters, where the deployment of the delivery of that application as well. Okay, so we've done an image build. Okay, we can copy that tag. Let's go and have a little look at that. Okay, so image was built, hopefully. Yes, awesome. That was good. That's run. There's doing some image scanning. Okay, there were some vulnerabilities because I've configured Gripe inside my cluster. Again, this is something that I'm interested in because I want to ensure that if there is any, and I've configured a policy inside my clusters to say, hey, if there's any errors or major fatal warnings, that change is not going to get into any of my run clusters. And this is configured by me as the application operator. As it happens, there's only some low and medium. I think there's no, CVE, so the supply chain is going to continue. And, and what we should see, config writer. This is where we're going to generate some Kubernetes resources. We're actually going to use Knative as a platform operator. That's what I've decided. And I'm going to write that configuration into our GitOps repo. So if we go here and hit refresh, yes, there's a Git repository. Now, the granularity is quite thin, so one Git repository per workload I created. So you probably, where a place I've worked before, you change that depending on your company. You might have one Git repository per cluster, or maybe one giant Git repository with different people having permissions. But we've just used one Git repository to publish this configuration into. And as a result, I did promise you no more YAML, but this won't last long, I promise. This is some YAML that was generated. This is, as you see at the top, this is Knative. You don't have to know about Knative, but this is using Knative. This is a project, again, it's from the CNCF, in the CNCF, helping for running scalable applications, scaling up via traffic and lots of other cool features as well. You can have a look at. But as a platform operator, I decided that's what we were going to use because it actually has automatic scale down and scale up. And it generated everything. Now, also generated some Java options because as a platform operator, I chose to actually add some of these GC garbage collection issues as well, environment specifics. It's not to say application developers can't set these. It's just you may want these to be set at a more at a global scale. Okay, so let's have a look. We mentioned about that deliverable, so we should have a deliverable. Let's go and actually have. Let's do. What was the, let's do that. Workload, we're going to get that workload now. And now we can see, hopefully, it might take, okay, this is our application that we've just built. Now, again, just going back, there was no pipeline in here. There was no Docker file. There's no Kubernetes resource in here. There's just the source code. Now, you may want to have those things in there. We're not saying that you can't. It's just the control is being inverted and it is having been applied to in the supply chains. And that is being governed in a centralized place if you want standardizations across all of your applications, across all of your repos, all of your teams as well. And that's where some of that strength comes into. I think we've only got 8 minutes left. I was going to take that one of those deliveries and put it into a different cluster and subscribe. Maybe we can do that if there's no questions, but there's 8 minutes left. So I thought maybe it's worth me stopping talking and seeing if there's any questions at all. Yes, hello.
Hi. First of all, thank you for the presentation.
Thank you.
I have a question about the resulting information from this specific steps, for example, the vulnerabilities, or if we run tests, where do I get the result? Maybe if there's a failure in a test, or the list of vulnerabilities. Is this somewhere in the YAML file in the status fields, or?
Yeah, it depends on what's doing the scanning. So there's different implementations. I think Gripe was this one. I'm not sure if they were in a CRD or if they were actually, they're published into an endpoint. I think with Tenzu Application Platform, we just publish them into an endpoint, something that's actually part of the platform. But you could write them into a CRD or publish them to somewhere else. I'm not sure where other, like TriviDB and other scanners put those, but maybe if we come back to the booth afterwards, we can actually figure that out. And I know just the person to help answer that question.
Thank you.
Okay.
Hello.
Hello.
Thank you for the press and the demo. So there's something that I didn't quite get from the presentation. I think you said that with cartography you can anticipate the CI/CD kind of for the project.
Sorry, anticipate or
You can basically guess the CI/CD for a project. Or did I get it wrong?
no, yeah, not quite. But I think that's something. So the only examples we've got working with other CI/CD tooling at the moment is Tekton, but we've got something around Jenkins soon. They will be. They will have to be. We'd have to. Well, need to be declarative, configuring so that we know in the supply chain that we need to call out to a Jenkins or a Bamboo or GitHub Actions or Tekton for those things. There's nothing automatic. But as a developer, though, you would actually see that out of the box because that's from the supply chain ownership. That's the app operator's responsibility. So as a developer, you can continue to work, and depending on what the other CI systems people do, the app operator has chosen, then we could leverage those. I think there's also, I mean, the realization is that my background, I've worked with Jenkins for many, many years and other projects around with CI/CD. There's a huge amount of investment that people have made in these, their release automation tooling, a huge amount of investments in teams and processes and cultures, totally recognizing all of that. So this isn't a replacement for these those toolings. We certainly want to be able to work with them and integrate with them. I think over time, I'd like to see more of these traditional workloads actually running more Kubernetes native, leveraging things like Tekton as well. But if we can have that control and consistency by the supply chains, we're using Cartographer, and then over time actually to continue our journey to be a bit more cloud native. Maybe we're moving certain workloads from a Jenkins into a Tekton, for example, but remaining everything quite consistent. I think that's where I'd like to see some of that. And I don't know if that answers your question, but it's...
Yeah, pretty much. Do you think in terms of observable, you know what I mean?
Observability? Yeah.
Thanks. Like, is it something that this tool can provide? Because with the supply chain and all this.
I mean, to a degree, but one of the things I love about Kubernetes is just it's built on all these open APIs, and there's so many observability tools out there that do a really great job about that. So, we're integrating with things like, capture metrics using Prometheus. I mean, a lot of applications will produce metrics that for Prometheus can be able to scrape, consume, and then building up and consuming that into other observability tools, whether that's something running inside the cluster, maybe something free of charge, or some of the Grafana types of observability, or some of the bigger, wider application, SaaSes as well, the Datadogs or your Cloud Watches or your GCP, whatever the stat drivers, for example. So I think there's a fine line of how much observability you want to give. I think totally things like trends of how your supply chains, how long a CI pipeline, a Tekton task might take. Are there any peaks? Maybe there's something that's been introduced, like there's a bad test, and maybe all of a sudden, you can trail that back. That your supply chain starts taking an extra hour every day or something like that. So trends and history. Personally, I kind of love all the DORA metrics as well, and the mean time to recovery, change failure rates. But so there's certainly, with all that beautiful information, all these metrics and everything, I think there's a line. I think observability specifically, I think that's best set for those other tools around, and ensuring that we're presenting those metrics so that they work well and we can capture those. People can observe the system. But I do definitely think there is an observability around supply chains where the lines get a little bit blurry, but there is absolutely a place for it. Yeah.
Thank you.
Okay. 2 minutes left. Go on, we can squeeze maybe another one or two. If not, there's there's some links. I think I'm going to be down. There's a VMware booth. There's a big Spring logo downstairs. Maybe come and have a chat. We can talk about anything. Doesn't have to be about this. Anything geeky as well. Miss talking to people, to be honest. So yeah, if you fancy that, there's some information, some links on Cartographer and Tanzu application platform as well. Happy to talk about any of those. And if you're interested in getting involved in any of the open source projects, it's not just Cartographer that TAP's involved in. There's tons more. Then love to to come and talk to us about that as well. I'll just say thank you, everyone, because I was a little bit apprehensive before, because I'm sure everybody is at this, coming back online and everything. But yes, thank you very much anyway. I enjoyed that. So, cheers.